Hi there, this is Professor Eckhouse, and I'm going to talk today about exponent rules. Today I'm going to be talking in this video about these two topics, and then in the next video, part B, I will talk about these two topics. There's a lot of examples. This takes a lot of practice. All right, so first you need to know what a base and an exponent is. So I've got four different looking examples here. The first one is just a 2 raised to the 4th power. I'm going to color each of the bases yellow. So the 2 is the base. Pause the video and see if you can figure it out yourself. All right, so the x, the 3x is the base, and the -2 here is the base. So what are the exponents? Well, those are all of these. So another word for exponent is power. So we will say to the power of 2. And another word that we use is the degree of the term. All right, so let's move on. Explain the difference between 3x and x cubed. So see if you can do it. So pause the video and think about it. All right, so 3x is x plus x plus x, whereas x cubed is x times x times x. See the difference? All right, so we call x plus x plus x repeated addition. Okay, so that is repeated addition. Whereas x times x times x, what do you think? You probably guessed it, repeated multiplication. So when we have a coefficient out front, it's counting how many times it's added. When we have an exponent or a degree or a power, that is counting how many times it's multiplied. All right, so let's practice this a little bit. Pause the video and identify the exponent, the base, and then simplify as much as you can. All right, so, oh, I switched my colors, didn't I? But anyway, the exponent is going to be these things here. Those are all the exponents. So let's identify the base. Is the 2, the 1/2. The base here is not the 3, it's the x or the y. Here the base is the 3, but not the negative. And here the base is the -3. See the difference? So take a moment and note the difference between these two. All right, so now let's, if you did not simplify these yet, you might want to go ahead and try that. But 2 cubed means 2 times 2 times 2, which is 8. 1/2 cubed means 1/2 times 1/2 times 1/2, which is 1/8. There's nothing I can do with the third one because it's just variables, so 3x squared y cubed. And then this next one is -3 times 3. Okay, the negative is not squared, so this is -9. Whereas the next one is -3. I'm going to use parentheses to let you see. If you don't put parentheses, it looks like -3 minus 3. So parentheses are really necessary on stuff like this because of the negative signs, and you get 9. Okay, so please beware of the difference between those two things. You'll see it a lot. It will mess you up a lot in algebra, so be careful. All right, so moving on, we're going to talk about evaluating exponential expressions. So I've got this all set up for us to put the numbers in. And I did that on purpose ahead of time because I really wanted you to take a moment to see the difference between all these. So the first one is 3x squared. And notice what I did here. I put these parentheses here, and I'm going to fill that in. Okay, so I will fill that in with this -2 that I'm going to be putting in each one. Okay, so we're evaluating the following expressions for x equals -2. That means every time I see an x, I need to put a -2 in where it goes. So use parentheses around the variable you are evaluating. It will save you a lot of trouble with negatives. All right, this next one is 3 times -2, the whole thing squared, because this time the squared is on the outside of the whole thing, 3x. The next one, 3 times -x squared, means I'm only squaring the -x. So now, I've kind of made a mess here, so let me erase some of this for you. So now I've set this up so that we've got 3 times negative of -2. All right, now that I've done that part for you, pause the video and see if you can get the right answers here, because this takes practice also. Working with negatives causes people to have lots of places to make mistakes, so it just takes practice. All right, so the first one, you're going to get 3 times negative 2 squared is 4. That's 12. The next one, we need to do the 3 times negative 2 first, so we get negative 6, and that is squared, so we get 36. And then the next one is 3 times negative of negative 2 is 2 squared, so it ends up being basically the same thing as the first one, 3 times 4, which is 12. Okay, so if you missed any of those, just pause the video, think for a moment, try to figure out what it is that you did wrong. All right, so moving on, we are going to use the product, quotient, and power rules. So we're starting with the product rule. So we've got an example here for you, x squared times x to the 5th. So let's take a look at this. And we've got x squared means x times x. X to the 5th means x times x times x, repeated multiplication. All right, so how many x's do we now have? Do I really need the parentheses? No, I don't. I just wanted to show you the two groups. So I get x to the 7th. There's 7 x's. So what do you think we did with the 2 and the 5? You guessed it, we added them. So the rule for product rule for exponents is as long as the base is the same, so the base must be the same, we get to add the exponents. All right, so we're going to do that by saying x to the a plus b. So that's our product rule for exponents, a plus b. All right, so now try a few examples. So pause the video and give these all a try, and then check to see if you got them right. All right, so the first one is x to the 6 plus 5, which is x to the 11. The next one is negative 2x. The base has to be the same, so notice negative 2x, they have to be exactly the same. To the 3 plus 4. So that becomes negative 2x to the 7. We're just going to stop there. You'll see some problems like this in the homework, and they say not to simplify the base any further, so that's what we're going to do here, just so you have some familiarity with it. All right, the next one, the base is t, so we've got t to the 4 plus 7 plus 5, which is t to the 16. Okay, so here's another one for you. Give this one a try. All right, so we're going to have x to the, and I'm going to do these in separate parentheses so we can really see them, a plus 3 plus 2a minus 4. Now, we don't really need the parentheses, but I'm using them so you can see the two different things. If there's a subtraction, though, which you'll see later, you do need parentheses, so be careful. All right, so we get x to the a plus 2a is 3a, and 3 minus 4 is minus 1. So you might want to put parentheses around that. In the computer, when you use computer math programs, you have to put the exponent in parentheses. So I would recommend doing that. All right, so that's your final answer. All right, so now we're going to look at dividing two numbers with the same base. So again, I'm going to show you this. We've got x times x times x times x times x on top. That's x to the 5. And on the bottom, we've got x squared, which is x times x. All right, so what happens to two of the x's, top and bottom? Well, they cancel out. They divide out and make a 1. So what are we left with? We're left with x cubed. So what do you think we did with the 5 and the 2? You guessed it. X to the 5 minus 2 is x cubed. So you can stare at that for a minute and see why it is that we subtract those out. It's because they actually canceled. They divided out. All right, so the quotient rule for exponents is x to the a over x to the b, as long as the base is the same, is going to be x to the a minus b. All right, next one, we've got some examples for you to try. So simplify all of these and then come back and see if you got them right. All right, so this one is x to the 15 minus 7, which is x to the 8. The next one is t to the 8. What are we going to do with this down here? It's just t. Well, remember, that is t to the 1. So we're going to say 8 minus 1. So that's t to the 7. The next one, we're not going to mess with the base, just leave it as it is. So we've got negative 5a. And then think about the exponents. So that is 9 minus 4. And you can do that in your head if you'd like. But I just want to show you. Negative 5a to the 5th power. And we're going to leave it like that. So we don't need to take it any further for most of the problems. All right, now try this problem. All right, so we get x to the, and I'm going to put the exponent in a different color just to make it really stand out. We've got 2x minus 4 minus the thing on the bottom, and that is 7 minus x. And this is what I was talking about before. You have to be really careful with your signs. So I'm going to work it out so you can, I'm going to distribute this negative across both of those. And I would recommend not skipping this step. So we've got 2x minus 4, and then minus 7, and then minus a negative x is plus x. All right, so this becomes x to the, what do you think? So we've got 2x plus x is 3x, and negative 4 minus 7 is minus 11. And that's our final answer. All right, so the next topic is to raise a power to a power. All right, so here is what this would look like. We've got x cubed squared, which means x cubed times x cubed. Well, what is that really? We've got x times x times x. That's the first set. Times x times x times x. So how many x's do we have? We have 6. X to the 6. So people often ask, why do we multiply? Well, if you can't remember why we multiply to get the 6, write it all out with a simple example like this to remind yourself. It's because there are 6 x's there, so we x to the 6. All right, so the rule is x to the a to the b is x to the a b. We multiply when it's a power. Okay, so let's try some examples. So simplify all of those and then come back and check your answers. All right, so the first one, we've got x to the 3 times 6. So it's 3 sets of x and then 6 sets of those 3, right? So think 6 sets of 3. How would you do 6 sets of 3? You multiply. So that's x to the 18. All right, the next one is 5x is our base, so we're just not going to mess with that. And then we've got 3 times 7. So 5x to the 21. All right, and the last one, our base is negative 2. And we've got raised to the 4, raised to the 11. So 4 times 11 is going to give us negative 2 to the 44. We're just going to leave it like that. All right, next one. Make note of the difference between the product and the power rules. So just to kind of compare and contrast side by side, let's look at what these look like. 2 to the 5 times 2 to the 2 would be 2 to the 5 plus 2, which is 2 to the 7. Whereas 2 to the 5 to the second power is 2 sets of 5 2's, right? So we've got 2 to the 10. Different. Yeah? All right, next one, we've got x cubed times x to the 4th, so that is x to the 7th again. But now we've got 4 sets of 3, so we get x to the 12th when we have the power rule. All right, one more product rule. So we've got 5a to the 6 plus 5 is 11. And fix my colors here. And then we've got... Interesting. All right, so here we've got 5a to the 6th to the 5th power. So 5 sets of 6 5a's. So we get to the 30. All right. So that is the end of this set of topics. Continue on to part B to learn more exponent rules. Thanks for watching.